Hello, everyone. Nice to see you all. So I am Ruchika Goel. I'm a product manager on Cloud Run team. And today, we are going to talk about how you can architect zero trust security for your applications on Cloud Run. Joining me today are my very talented coworker, Shane, and our amazing customers, Rio from Entity Docomo, and Yusei from Entity Data. We have a very packed agenda. First, we are going to talk about all the end-to-end security features on Cloud Run. Then we'll dive deep into identity-aware access controls. Then a customer will show you how they are creating secure apps and agents on Cloud Run. And finally, Shane will talk about service-to-service communication. So let's dive into it. How many of you know about Cloud Run here? Oh, that's great. So anybody who's new here, let's have a quick recap. What is Cloud Run? Cloud Run is a fully managed platform that is built for scale. You can run any container on Google's world-class infrastructure in a fully managed manner. You do not need to provision any servers, any VMs, or any clusters. It is a hyper-elastic platform. It can scale to tens of thousands of containers within 10 seconds. And the best thing, you only pay for what you use. You can run any code, any framework, and any library, and you only pay when your code is running. So now let's get back to our talk, which is what is security on Cloud Run? So historically, we have always seen network security as like an M&M, where you have this hard, crunchy outside shell protecting what's inside your network, the soft, chewy center. That implied that once you're inside your network, you can trust everything. However, with zero trust, we flip that. There are three core principles of zero trust on which we focus. First, we assume that all network traffic is a threat at all times, whether your network is internal or external. Second, we enforce the principles of least privilege access for every identity in your system. Lastly, we always monitor. We continuously observe, and you continuously verify. Now let's see how Cloud Run is built with these zero trust security principles built into the platform. Cloud Run provides robust role-based access controls and context-aware access controls for every identity in your system, whether it's a human accessing your application, a user, or an agent. All the data in Cloud Run is encrypted at all times, whether it is at rest or it is in transit. You have strong multi-layer isolation between your containers. Cloud Run provides built-in observability for your network and your services. And it even comes with runtime threat detection capabilities. Now let's dive deep into each of those pillars and how Cloud Run provides you more secure controls, now even more secure. First, Identity-Aware Proxy. Identity-Aware Proxy can now be enabled directly on your Cloud Run service on your ingress path without the need of any load balancer and complex network setup. For service-to-service communication, Cloud Run has considerably simplified how one service can connect to other service in a secure manner with automatic service identity verification. And lastly, every Cloud Run workload, firstly, starting with agents, get a strongly attested, uniquely identifiable, SPIFFE-based identities assigned by defaults. This is coming very soon for all your Cloud Run workloads, whether you're deploying Cloud Run services, jobs, or worker pools. When it comes to encryption and isolation, Cloud Run provides 2 layers of sandboxing for all your container code. With direct VPC integration and by setting your ingress settings to internal, you can ensure that all your traffic remains on the private network. Lastly, data is always encrypted, and you can even bring your own managed keys, encryption keys, if you want. When it comes to the last pillar of zero trust, which is monitoring and response, Cloud Run now provides out-of-box observability integrated with service monitoring to provide golden signals and create service topology. Each container deployed on Cloud Run is scanned for vulnerabilities, and even when you have containers that are running on the platform, you can check them for threats or runtime attacks like if there's a malicious binary that is being executed, you have reverse shell attack, or somebody is doing crypto mining. You can also utilize new capabilities of Cloud Run, like Gemini Cloud Assist, or you can use Cloud Run SSH to SSH directly into your containers and investigate for threats. Now let's dive deep into identity-aware access controls on Cloud Run. And let's go beyond just network security and achieve zero trust for Cloud Run. We are excited to announce that Identity-Aware Proxy on Cloud Run, a direct implementation, is now GA. Yeah, as you can see, IAP can now be enabled directly on your Cloud Run ingress path. You do not need to set up any load balancer or do any complex network setup. You even don't pay for a load balancer anymore, just for protecting your front-end applications. With the GA release of the feature, we have made major enhancement compared to its preview feature. You can enable IAP. It works everywhere. Whether you have projects within a GCP organization, or you have projects that are not even tied to a GCP organization, you can use IAP on Cloud Run. It secures everyone. You want to add users who are within their same organization as your Cloud Run service, or you want to enable access to users who are outside our organization. You can do so with IAP on Cloud Run. Lastly, it's extendable. What do you do if you have your own identity provider? You can use Workforce Identity Federation with direct IAP on Cloud Run. You can even manage external identities. Let's see things in action. So here we have a demo of how you can enable IAP directly on a Cloud Run service without the need of any load balancer in a single click. All right, so I have this application that I've deployed on Cloud Run. As you can see, it's publicly accessible. I try to access this application. Anybody can reach it, but that's not what I want. So I go back to Cloud Run UI, and I enable IAP with this click of a button. I hit save. It takes up to a minute for IAP settings to get applied. I go back, and I try to access this application now. As you can see, it has now redirected me to a login flow. I did not give anybody access yet, so I go back, and I edit IAP access policies, and I add a valid user on this. For the purpose of this demo, I'm just adding myself. So I say to IAP, hey, Ruchika is a valid user. I click Save Settings, and that's it. Now, when I try to go back and access this application, IAP is protecting this Cloud Run service. It will redirect to Google SSO. I provide my login ID, and I provide my login password. IAP validates that, yes, Ruchika is a valid user for this application. It uses Cloud IAM. And then ultimately, it logs me in. So just a few seconds, and we'll see that it has validated that I am a valid user. That's it. I can access this application. So let's try to do something. I want to look at summer hats, which are in low stock on my application. Oh, I'm getting an error. That's because right now I've just deployed the front end of this application. In the next part of the demo, my colleague will show you how you can create your front end to a back end using service-to-service communication. But before we go there, let's look at some of the security controls that we are adding specifically for your agents on Cloud Run. Can I go to the next slide? OK, let's look at some of the security controls that we are adding specifically for agents on Cloud Run. So these are all the features that are coming from Gemini Enterprise Agent Platform directly or for your agents that you deploy on Cloud Run. First is agent identity. Every agent that you deploy on Cloud Run will get, by default, a strongly attested SPIFFE identity assigned. For your agents that you want to limit access to other agents and MCP servers or tools, you can set up authorization policies with Agent Gateway. You can even securely connect to your MCP servers that are deployed on Cloud Run using this recommended security method, which is OAuth, which is now built in very easily on Cloud Run with IAP. And next, we are going to see a demo of it. And lastly, for your agents that need to act on behalf of user, the flows are now very simple by using Auth Manager on Cloud Run. Now, let's see a quick demo of how I can connect my client tool, basically Gemini CLI, to an MCP server that is running on Cloud Run. The whole flow is authenticated using OAuth as the standard. All right, so here I have deployed an MCP server, which has two tools, very basic tools for doing addition and subtraction. As we know, models can mess up math sometime. So I'm going to deploy this MCP server on Cloud Run. Look at the two flags that I'm passing. One is functional type MCP server, which basically tells Cloud Run that this is an MCP server, and I'm enabling IAP by providing --IAP. Once the service is deployed, I update my IAP settings to do programmatic access. That's because I'm going to use Gemini CLI to connect to this MCP server. The last step of this process is I update Gemini CLI settings, and I tell Gemini which MCP server to connect to. Here, I am updating the settings, and look at the configuration I've provided. I'm saying connect to this MCP server, which is a Cloud Run service. I'm saying enabled OAuth for this server, and I'm providing my client ID and my client secret. I give back the redirect URL where my Gemini CLI is running to my local machine. Let's try to connect to Gemini and see if it can discover my MCP server and if it does OAuth. I look at the two MCP servers that I've deployed. Okay, let's try to connect to MCP on Cloud Run that we just deployed. Let's start the OAuth flow. I just say MCP auth, MCP on Cloud Run, and it's now asking me to authenticate. Gemini CLI now automatically redirected me to log into this application. This is all done by IAP, which I enabled on MCP server. And I provide my login credentials. I do multi-factor authentication, and I'm authenticated. Now, I go back to Gemini, and I'm going to try to use this MCP server now. So we added two tools, one for addition and one for subtraction. Let's try to just add two numbers on Gemini CLI. Here, I'm saying add 2 and 4, very simple. And we'll see that, yes, it's using the MCP server on Cloud Run to do this. All the communication is secure. It's using the OAuth credential. It has validated me as a valid user. And now we support MCP OAuth with IAP directly for your on Cloud Run for your MCP servers. Now that's it for this demo, and now I'd like to invite on stage Rio to take it forward.
Thank you, Ruchika. Hi, everyone. I'm Ryo from NTT Docomo, the largest mobile carrier in Japan. Joining me is Yusei from NTT Data, a Google Cloud Premier partner with a global strategic partnership. Together, we built a data platform I'd like to walk you through today. The question we keep asking ourselves, how do we use open data access to everyone in your organization without compromising security? Today, I want to show you how Zero Trust principle on Cloud Runs made both possible at the same time. Let me paint a picture. Imagine you are a marketer at a large enterprise. You need a data plan to a campaign, but you are not a specialist. So you send a request to an analyst. The analyst is great at their job, but they already have 5 requests ahead of yours. So you wait. You wait 1 week, sometimes 2. By the time the answer came back, the campaign window has passed. We tried to close the gap with BI tools. We made them available to the whole organization, but adoption was low. The tools were simply too complex for non-specialists. Our goal, cut 90% time it takes to go from question to answer. Not by hiring more analysts, but by empowering anyone to answer their own questions. Our challenge was clear. Reduce the time spent on data utilization processes by 90% and make data access truly self-service. The answer we arrived at a massively intuitive data platform. And the foundation of the platform is Streamlit on Cloud Run. We provide Streamlit apps as data products, a data platform built entirely on Google Cloud, where anyone can use data, not just data specialists. But here's the catch. Opening data to everyone creates a real security challenge. When any employee can access sensitive business data, every access must be authenticated, every service must be isolated, and every deployment must be verified. The foundation has to be zero trust day one. Foundation had to be zero trust from day one. And that's exactly what Cloud Run gave us. On the left, you can see our data product gallery. Think of it like an app store. User browse and find exactly the tools they need. On the right is a live streaming app. Simple, purpose-built, and ready to use. What users never see is a security layer underneath, IP verifying every identity before a single byte of data is returned. Secure by design, invisible in practice. The results speak for themselves. By the end of March this year, 5,300 users inside our company are actively using the platform. The adoption has contributed to 450,000 hours of operational time savings. Behind those numbers, 163 Cloud Run services powering this platform, and we achieved this without a single security incident tied to the platform. Even one of the 5,300 users accesses to data through the same zero trust architecture, authenticated, authorized, and auditable. Now, I'd like to walk you through architecture that made this possible and where we are taking it next. Our architecture rests on 3 pillars. The first, anyone, anytime. Anyone can access data does not mean open a door. It means a verified identity. Every employee signs through the Identity-Aware Proxy with their corporate identity. Now, no special account, no friction. But behind those simplicity, IP verify requests every time. That's the trust in practice. The second, security and reliability. Cloud Run's container sandboxing fully isolate each app. A bug in one service never cascades to another. Auto-scaling absorbs traffic spikes, and scale to zero keeps costs near zero at idle. The second, security and reliability. The combination of resiliency and cost efficiency are just like building it culture. Teams from the field started shipping their own data products. The platform made it safe to experiment. The third, supply chain security. A platform serving 91 subscribers is a high-value target. Our CI/CD pipeline enforces shift-left security. Every deployment is scanned and verified before it reaches the production. Cloud Run managed runtime means Google handles infrastructure security. We focus on investment on the application layer. The result is flywheel. Secure infrastructure gives developers confidence. Confidence drives iteration. Iteration improves user experience. And better experience drives adoption. Each time makes the platform stronger. We made this significant progress in data democratization, but as the platform scaled, the definition of normal changed with it. Over 160 apps, like a success, and they are. But it also means users face a long list with no clear starting point. A marketer trying to run campaign doesn't know which app to open. Pick the wrong one and lose time. Find one that fit, and you're back to waiting for analyst. And even when you find the right app, real business decisions don't need to fit into a single domain. user analysis, campaign measurement, target extraction, each lives in different app. And with different app, each requires manual handoff between steps. And we'd move from data silos to app silos. But here is the thing. Each app is truly good. Each app carries a trusted domain knowledge built by the people closest to that program. We didn't need to tear them down and build a super app. What we needed to was give AI access to that trusted domain knowledge, while keeping the same zero trust security guarantees that made this platform trustworthy in the first place. Okay, next is Yusei. Over to you.
Thanks, Leo. Hi, I'm Yusei from NTT Data, a global IT services company. There's a question we keep coming back to. How do you give AI domain knowledge? We have 163 apps, each one built by the people closest to its problem. Years of insight encoded into trusted workflows. That's domain knowledge, and it was already there. We didn't build a super app. We didn't start over. We converted each app into MCP server so the agent could call those workflows directly. Users don't need to navigate. They just ask. And the light analysis happens. That's the foundation. Now, let me show you the structure we built on top of it. We introduced a supervisor-style multi-agent system. One coordinator agent, multiple specialist sub-agents. The coordinator receives what the user wants and routes the work to the right agent. Now, here's one thing I want you to remember. More agents mean more risk. If every agent can talk to every other agent, you lose control. So we used service-to-service authentication on Cloud Run to explicitly limit which sub-agents the coordinator can reach. The coordinator only sees what it's supposed to see, no expected behaviors, no runaway chains. The system stays predictable, even as it grows. Predictability is a security property. Keep that in mind. Let me show you what this looks like in practice. Watch how the agent moves from single business question through customer feedback down to the exact store's driving problem. The user opens the agent and types, what are the key business challenges we should address? No abstracted, no analysis method specified. The agent received one question, and now it's deciding how to answer it. The agent explores what's available and offers 3 approaches. The top recommendation, analyze customer feedback. Behind this are thousands of individual voices, appreciation for sales representative, questions about a billing plan, feedback on the in-store experience. The agent groups them. It surfaces the themes with the most native signals. Sorry. And the user, sportsman, communication, quality. Let's focus on Tokyo, go deeper. The agent responds with a link, not just any link. It's a direct link to our existing network quality app, one that infers signal strengths from payment logs. Every through transaction, every fine payment, map to location. The link opens it with Tokyo already filtered in. One click, you land exactly where you need to be. Just a moment, please. The app opens, and heat map. Tokyo spread across the screen. That means poor network quality. The user scrolls, one area stands out around Tokyo Station, clearly red. Then the user goes back to the agent and says, analyze the Tokyo Station area in detail. Another sub-agent learns, this time, at the store level. The result, specific stores dragging down the quality scores for the entire area. From where the business challenges to the specific stores with a measurable problem in one conversation. That was powerful, but I owe you the other side of this story. When you add a multi-agent layer, you add environments to manage. The app environment, the agent, and MCP environment, each with its own dependencies, custom images to maintain, patches to apply, over and over. This kind of repetitive work doesn't scale. It drains engineers, not just their time, but their motivation. And then there is a security problem. More agents mean more outbound connections. Can you monitor every single one? You cannot protect what you cannot observe. We were already there, buried in alerts, never to keep up. Complexity is a cost, and it compounds. Our answer was simple. Let Cloud Run carry it. Simple systems are predictable. Predictable systems are secure. For operational burden, we switched to deploy from source code. Google manages the base images. Google applies the patches. We write code. That's it. The attack surface shrinks not because we worked harder, just because we removed an entire category of manual work. For security visibility, we added 2 layers. Google Threat Intelligence blocks malicious outbound traffic at the edge before it reaches anything. Cloud Run threat detection catches anomalous behavior at runtime inside the continuum. One layer for what goes out, and one layer for what happens inside. If one is bypassed, the other catches it. That's the defense in depth. Our engineers stopped chasing alerts and started building again. We built something powerful, but powerful with a control with a reliability. Every new agent is a new attack surface. Every MCP connection is a new purse. Our question was never, can we add more? It was, can we see what we have built? Our answer was, delegate, not abdicate. Connect your apps, don't replace them. Domain knowledge survives, nothing is lost. Hand management to Google. Design your system to work with source-based deployment. And do that, you never touch base images again. Let security work at the edge and inside a continuum. Your team stops reacting and starts building. Security is not something you add at the end, and it's what makes the system trustworthy enough to grow. We will keep pushing this forward throughout this year and beyond. Each item in this roadmap is a step toward a zero-trust architecture built on the full capability of Cloud Run. Easy to use for our users, safe to operate for our engineers. That's all from us. Thank you for listening. I'll now hand it over to Shane, who will take us into the next topic.
All right. Thanks, NTT team. Now, shifting gears, we're going to deep dive a little bit on how we simplify service to service on Cloud Run. Now, as your agents and enterprise applications get more complex, security, networking, observability toil really become top of mind, right? With microservices, this really used to be some of this, more of a day 2 challenge. You build your app, then you figure out how to harden it. But with a lot of the agent and agent-assisted development now, this is now becoming a day 1 concern. And so the idea here is we're going to define identity-based boundaries, simple, secure, and observable out of the box for service-to-service calls. So like, let's say let's take an example where you have a front end calling a back end. At the front end, you have a Google managed sidecar. This will proxy the outbound traffic to a target backend, and it works closely with the Google Cloud control plane to essentially identify targets, and works and basically generates an OIDC, JSON Web Token, which is automatically injected as in the header with an audience claim of the front end for the service identity. Now, all those calls are TLS encrypted in transit and leveraging the run.app certs, and at the back end, Cloud Run already has an IAM invoker check to make sure that the principal that's bound to that service identity is allowed to invoke the service. Now, for each calling pair, we are also adding observability. So in this case, now you'll have golden signals, error rates, throughputs, latency, and they're all collected as OTel compliant metrics and observable through a Google centralized plane and class. And in this case, for agents, you would be able to observe them through agent observability. For apps, you can actually look at them through like app-centric service monitoring or app-centric observability as well. And in the future, we do plan to support additionally strong auth, which is, let's say we want to have mutual TLS, and you want to have a front end and a back end, now enabled with a Google Managed Sidecar. They can mutually verify before actually establishing a TLS connection. And we would have then supported in different formats, including bound tokens and certificates. But let's say we want to make this private. I want a private call. Well, we could actually still leverage this secure calling setup. You'd still get the automatic JWT injection, you'd still get the TLS encryption, you'd still get the IAM invoker, and you'd still get the observability. But instead, it'll just work with your existing VPC setup. Your front end will just egress traffic through that VPC, and the back end will restrict to only accepting internal traffic. So today, Cloud Service Mesh on Cloud Run is publicly available, and it actually does support the secure calling out of the box. You get your auth injection, you get your encryption in transit, you get service-centric observability, and you get the private calling, and it has a full stream of capabilities for advanced traffic management capabilities that are great for enterprise use cases, like calling GKE or GCE or other services. But for most developers, there's a high connectivity toil that is associated. You have to set up a Cloud Service Mesh resource, you have to set up an internal self-managed backend service, you set up your serverless neg, and then you have to manage these different HTTP routing YAMLs. So introducing service bindings. And so this is really to simplify your service-to-service calling setup for both public or private applications. And so it's great for single or cross-project calls on Cloud Run between services, GCP resources, or even agents and tools. So I have a Cloud Run service, I want to call another Cloud Run service. Or I have a Cloud Run service, I want to talk to my one NCP server via Google APIs. Or I have an agent, and I want to call another agent. These are all going to be supported by the service bindings in the future. But as part of service bindings, we will also introduce an ambient networking field. And that will allow you to configure on the front end for scoping that sidecar down to a regional or global scoping, so that you can ensure that, let's say you have a regional thing where you want to make sure that traffic is like isolated to a specific region, you can actually scope that down. And then afterwards, you would create that service binding network servicing resource. So the three things you need there is a source URI, a destination URI, and essentially a way that we would match the metadata of the backend. And so for Cloud Run, service to service, what we would do is you'd be able to specify a host name match with that backend service name. And in the future, this flow would also support the MTLS tokens and certificates. So let's go to continue our demo that we started earlier, the Mad Hatter, right? So we have two services, a front end and a back end. The front end will call the back end privately to retrieve the hats, and this will actually showcase a zero trust setup on Cloud Run. All right. So as you can see here, this is our app that we had. So there's the front end, and the back end is now already deployed. And in a moment, what you're going to see here is we're going to switch to CLI now. And the CLI will show to configure a service binding between the service and the destination. And I'm going to have to look here because here we go. Yep. So basically what you're showing is there's a host name match here to the hat demo backend. So now we're in the hat demo front end here. And that hat demo front end is actually showing that there's an ambient configuration that's scoped to regional. We have everything traffic egressing through the VPC, and we essentially have that binding set up here on the UI to the backend hat demo. In the source code, what we've done is we've replaced our mesh with a short name here for the actual service name of the backend. And then momentarily, what we're going to do now is we're going to switch over to the backend. And what we're showing here is the list of the CSV of all the hats that we're going to return. And we're also going to show you here in a moment that the networking is actually only accepting traffic from basically from internal sources. Now, we're going to call the backend privately and get some surprise hats. There we go, Trapper. Yep, I want a sporty visor maybe in stock. Hopefully, is it going to surprise me? Yep, there we go. And now, so this is what we've shown here is how service bindings can really simplify secure service-to-service calls on Cloud Run. Okay, that concludes our presentation.